Hi all. Let's start with the next video of transaction layer in PCIe. As we discussed in last video, transaction layer header types. In header types, as I told you, two types: three double words and four double words. So in that three or four double words, first double word will be the as we see in a format and types and TC value and EP value, length field, some ordering rules, some attributes. So we see some concepts. Those fields are as already I explained. We'll see for next double word. What are the fields is present in the next double word. So as we see in the PPT, next slide, you have a in transaction layer header type. Second double word will be the request ID and tag, last double word and first double word values. So overall we have a 32 bits. So 32 bits means 8 bits tag. Last double will be the 4 bits. First double will be the 4 bit. Remaining 16 bits are the requested ID. So let us take one example here. You will understand more clear. You have a RC. You have a EP. You want to read the data. Let us take example. I want to read the two 300 packets. Let us assume. From RC. It will send the request to read the data from EP to RC. So EP have a, let us say as example as you have a memory. In that memory you want to read the data from EP to RC. RC will send the request. So in this point requester will have a some ID, right? So every device we have a ID. So it will allocate here requester ID that particular tag. Let us take you want to read the 300 packets, the so and so length is so and so first double and last double values. So assume as each packet having a number that tag 1 2 3 4 5 like that. So 8 bits mean 256 combinations. After 256 combination again it will start again from the initial two. So one more will requested is complete. Tag means complete. One more with the first double word and last double word. Let us take you have a memory with the 32 bits. 0 to, let us assume as a in this field we have a 1 2 3 4. Let's example. Let's take something. One example. Let us. I want to read as 0 to 64. You have a address. So 0 to 64 each will be the 8. 1 byte, 1 byte, 1 byte. It will split as a 1 byte. So 1 byte. So where you want to read the data from specific location. Let us assume it's want to read from 0 to 64. Instead of writing 0 to 64, let us first by 2 bytes are I don't want to read the data. Remaining bytes I want to read the data. I means let us take example from 16. From 16 to 64 bytes of data I want to read. So you will enable based on that your request. So first double values will helpful for you have to read the data specific location instead of starting from ending. You will read the data specific location where you want to read the data from. So based on first double last double value helpful to specifically you where you want to read the data. Instead of starting, let us you have a 0 to 64. So instead of reading from 0 to 64, let us I want to read the data from 27 to 64. Based on this address, you will allocate accordingly. First double word, last double word values. We'll discuss more on about on this. What is the first double word values and last double word values? As of now, understand what is the request ID, what is the tag significant, what is the first double word and last double word values. So in this next to double word we have these fields based on the request from RC to EP. You will get the you need to allocate the information based on this information. Requester will send the request based on that tag ID with specific first double word and last double word fields. Based on that fields you will get the rate data from EP to RC. So this is the concept I am going to cover. Let's see the next concepts will be the first double word and last double word. Why it's needed. This we call double as a byte enable concept. So which bytes of data you want to enable to read the write the data specific location. So uh, first double word values will be the 4 bits. Last double word byte envelope value will be the 4 bits. Tag is each will have its own tag to sending request from RC to UP. Request ID also is specifically you have a request ID specific tag, specific number for sending request from RC to AP. So we'll see the concept of what is the first double word values, last double word. We'll see one example for that, then you will understand more clear. So byte enable concept means where you want to read data, where you want to write data from specific locations. So based on byte enable, what happen? Specifically you will get the specific data on that. So here will be the first double word will be 4 bits, so last double word will be the 4 bit. Each bit we called as in the while reading we called as a 1 byte. So let us take example, one example. Let us you want to read the data, let us assume 70 bytes. 70 bytes. 70 byte means each 70, let's take as a 72. So one double word will be the 4, right? 4 ones are 4 ones are 8. So 18 double words. 18 double words read the data, write the data. Let's take as a read the data. So you have a, let us assume 0 to 18. 0 to 18. You have a memory. We have a memory. Each 18 double words data. 0 to 4, 8, 12, 16. Let us assume 20. So in 4 also we have a each byte, right? 4 bytes. Here also 4 bytes. Here also 4 bytes. Here also 4 bytes. Here also 4 bytes. Let us assume say, example here, byte enable concepts here. Let us I want to read the 18 double words data, but I don't want to read the data from initial 0 to 20. Let us you have a RC, you have a EP. You are sending the request with 72 double words, 72 bytes of data, right? So you will send as a from RC to request from EP side. EP will send the data from EP to RC side. So by using byte concept, what happen? Specific location. I told like specific location you want to read. Let us I want to read the data from uh, year, from year to I want to read up to year. Let us assume 20, right? Let us assume year up to 18 year. I want to read from, instead of starting 0, I want to read the data from year, from 2 to 18. So what you will do, you should be disable these two pins. So what happen? First double word value what happen? 1 1. You want to disable first 2 bytes, right? So this is the value, first double word value. What is 1100? If you see in last double word, I don't want to read the data from 18. I want to read only up to 17. So what happen? You will give us a 0. Remaining 3 fields are 111. So this is the last double word value. So based on that, what happened using binomial concept, specific location you will write the data, or specific location you will read the data. So in this way, binomial concept it's helpful. So let's see the scenarios here. Binomial concept where you want to write the data or read the data specific location for zero length. There is no byte enable concept. Let us you want to read the data or write the data. If you take as a length equal to 0, means there is no there is no payload. So the length here binomial concept is exceptional concept. So length 0 it won't be there. Let's take as a length 1. You have a length 1, so you are writing 32 bits data. 32 bits means you don't have a 32 bits means 4 bytes. So 4 bytes means 4 bytes allocated on first double word only. So there is so last double word values, last double word will be 0. So first double word you can write. You are writing 32. You are giving length as a 1, but you want to write the data only two locations. Let us assume you want to write the 0 to 7 only, but you are giving length. Length is will mean with the minimum will be the 0 or next will be the 1. So you don't have an option like 0.5 length. So what happen? You will give as a length is 1, but you can write the data from 0 to 15, up to 0 to 15 only. Remaining fields you can disable. So what happen, you will give us a 1 1 0 0 1 1. 0 0 1 1 means this one will be the 0 to 7, this one will be the 8 to 15. After remaining 2 bytes will be the disable. So by using first byte enable concept in this, if you give length is 1, but you want to write the specific location 0 to 15 only, instead of 0 to 32, you will give as a first type byte envelope as a 0 0 1 1. So based on that you can give anything location, any one location, like you will give as a 0001 or 1000. Its combination value will be the up to 16 combinations values will be there for first 4 bits. So based on your specification you can write the data or you can read the data. For length 1, let us take one more scenario. Length 2. Length 2 means you have a 64 bits, so 8 bytes. So what happen, here also you can use here 2 bytes, 8 bytes, right? 8 bytes means first double word also present and last double word length also present. But here is a one condition, at least one 5 byte first byte enable must be enabled. Here is a last length 1, you don't have a last byte enable value, it will be the default will be 0000 only. For if you use length 2, it's saying like at least one first byte of d double word must to be enabled. So let us take scenario where, let us you are giving as a length is equal to L is equal to 2, your assumption, but you are writing data, means let us assume you want to write the data from uh, 15 to, let us assume as a 40, let's take as a 63. So what byte enables you will give, first byte enable will be the 0 0 1 1. 0 to 15 you don't want to write the data, so after that you are writing data, so this will be the 1100. This is the first byte enable. Last byte enable you are writing fully, so 1111. So based on that you can choose. Here is the concept is saying like any one of the byte enable should be enabled. This line is indicate any one of the byte enable should be enabled first byte, first double word value. So you should not put as a all zeros in first double word values. At least one should be present. That is the condition here. Length more than 2, first last double values will be continuous. Means let us you are right, you have a memory with 0 to 63 bytes of data. So it should be, you want to write the data means 2 to 48. You can write 2 to 48 based on that byte values. You can write the data from 4 to 63. You can able to write the data. It should be continuous. It should be continuous. You should not choose like I want to write the data from 0 to 7, and I want to write the data from 15 to 48. You cannot choose like that. So in middle you should not give as a non-continuous. If you give non-continuous, what happen, it will binomial concept will be the not helpful. So it should be continuous, then only it will be the very clear light where you want to, from where which location to which location, where you want to read the write the data from the using byte enable concept. So it will be the more than length too, then only will be the these conditions will be applied. So this is the concept I am going to cover in this video related to second double word fields, and what is the significance of first double word and last double word values. Based on specification, you can enable and disable the specific locations where you want the reader data, where you want the read data. So based on specification, you can enable and disable. If you have any question, please let me know. Thank you.